Okay, so we now know how to add and subtract matrices that are the exact same shape, that have the same dimensions, and so that's not a big deal. Now, in fact, let me just tell you a little bit more language. So these are examples of matrices. This is a 3 by 2, for example. This is a 3 by 1, and so on. Now, but numbers alone now, just naked numbers by themselves, like a poor little 5 or poor little 4, these are now referred to sometimes as scalars, just single elements, just a number rather than a whole list or an array of numbers. So these are sometimes called scalars. So one thing we can do with matrices is to actually multiply them by scalars. And again, not a surprising outcome. For example, if I take this matrix, which is a 3 by 1, and multiply it by 5, what do you think I would end up getting? Well, I'd get another 3 by 1 matrix, and you'll never guess the answer. Yes, that's right. I take each of these elements and multiply it by 5. So I'd see, in this case, what would the answer be? Well, this may just shock your world. But I would see 5, 15 minus 5. Not a big deal. So scalar multiplication of a matrix by a scalar is just literally to take that scalar and multiply every single element by that scalar. So for example, this would give you another 3 by 2 matrix, and you would get 4, 16, 0, 28, minus 4, and 8. So again, it would be the exact same size, same shape. So scalar multiplication is not a big deal. Just to illustrate that, in fact, we can combine these ideas together. I could take two people, like this, and ask for this operation. Let's take 5 times this and add it to 4 times this. So put a plus sign here. So now I'm asking for matrix addition and scalar multiplication at the same time. Ooh, this is getting tricky now. Well, we can only add matrices that are the same shape, but these are the same shape, so we're okay there. And everything has to be multiplied by 5, and then I add it to what we get when we multiply this by 4. So in this place, I'd have a 5 and a 4, and when I combine them, I see a 9. Here I see a 15 and 8, and so that would be a 23. Here I see a 10 and a minus 4, so that's a 6. Here I see a 5 and a 0, so that's just 5. Here I see a 20 and a 12, so that's a 32. And here I see a 0 and a 20, and so I get a 20. So again, you can just, scalar multiplication is not a big deal. You just literally multiply it through everywhere, and then you have another matrix of the same shape. Do the same thing here, and then you can combine or subtract or whatever you want. So multiplication by a scalar multiplication, not an issue. Now, multiplying two matrices together, whoo, you'll see.